Hello friends, in this video we will see more problems on AC circuits. Let us start with question number 1. An AC voltage source of RMS value 20 volt. The active and reactive power consumed by the load is dash and dash. Means in first part they are asking you the value of P, that is active power, and in the second part they are asking you the value of Q, that is nothing but reactive power. So in this place we need to substitute the value of P, which is called as active power, and in this place we have to place the value of Q, which is nothing but a reactive power. Let's see how we can handle this. This is simple series circuit where I can add ZS and ZL, so I will get Z equivalent. Suppose if I take voltage upon Z equivalent ratio, I'll get what? Current. We'll see what is to be done when I get current. So we can say that current I is simply voltage upon Z equivalent. Am I right? Then I is equal to, voltage is, as you can see, it is 24 at an angle of 0 degree. Divided by Z equivalent, if you calculate, it is ZS plus ZL. Simple. Z equivalent is ZS plus ZL because they are connected in series. So real part gets added, imaginary part gets added. Effectively what ZL I will get is, it is 8 plus 6J. Is that right? Suppose if I want magnitude of I, then at numerator as well as denominator, at both the side I have to take magnitude. As you could see, the numerator was 24 at an angle of 0 degree. What is the magnitude? It is 24. And I'll take magnitude of 8 plus 6J. Magnitude of a rectangular part, that is A plus JB, is nothing but under root of A square plus B square, meaning 8 plus 6J will give you magnitude under root of 8 square plus 6 square, which is nothing but 10. So the magnitude, what I get is, the voltage value is not 24 but 20. So we should modify this to 20. So it is 20 divided by 10, which becomes simply 2 ampere. Now try to understand the question. They are asking us active and reactive power consumed by the load. Load means ZL. Am I right? We should understand ZL is having real part and imaginary part, out of which real part consumes P and imaginary part consumes Q. And it's very simple to say that P is given by I square times R and Q is simply I square times X, where I is nothing but magnitude of I, or it is also called as I RMS value. In this case, the magnitude of I that we have got, I can treat that same current as, of course, it is I RMS value. Because every time the voltage or current that you get in a constant form has to be RMS value only. In that sense, I can say power is mod of I square times RL. RL means real part of ZL. So I square becomes 4 and real part of ZL is 7. So it becomes 28 watt. So at first place I can say it is 28 watt. Whereas to get Q, it is simply magnitude of I square times XL. XL means it is not inductive reactance. Here XL is nothing but reactive part of the load, that is ZL. So now it becomes 4 multiplied by reactive part of the load is 4. So it comes out to be 16. So what is the final answer? Is 16 volt ampere reactive. So 28 watt, that is active power, and 16 volt ampere, it is nothing but your 28 watt is your active power, and 16 VAR, that is nothing but volt ampere reactive, is nothing but your reactive power that is consumed by load. Let's move to the next question now. Next question says, find voltage across capacitor for the following circuit. As you can see, it's a series circuit. It's a series circuit through which if I manage to get I, simple, current into reactance part of the capacitor will give me voltage across capacitor. So I can say simply voltage across capacitor is nothing but I vector into ZC vector, or I can say it is I vector, ZC vector is nothing but minus JXC. Therefore VC vector will be minus J times I times XC. So I'll try to get I first and then I'll substitute it. The value of I is nothing but total voltage 100 divided by total impedance in the series circuit. So as you can see, it is 10 plus J20 plus minus J20. So J20 and minus J20 will cancel each other. Effective impedance is just 10. It means I is simply 10 ampere. In fact, if you can see here, XL value is matching with XC value. It means it is nothing but a series resonance circuit. In series resonance circuit, otherwise circuit becomes a resistive circuit. In a way, assume as if inductor and capacitors are not present, only 100 ohms and 10 ohms resistance is present. In effect, you will always get current equal to how much? 10 ampere. Now in that case, I can substitute VC vector as minus J. Your current value is nothing but 10 multiplied by the value of XC is 20. So it becomes minus J 200 volt. Now, if you look at the options, all the options are in polar form, and what you have got is a rectangular form. I'm sure you remember minus J 200 can be written as positive 200 at an angle of minus 90 degree volt, which is nothing but option number C. So option number C is the correct option. That is nothing but voltage across capacitor. Let's move to the next problem now. Question number 3 says, for an series RLC circuit with Q factor equal to 100, if the values of R, L and C are doubled, then the Q factor is. In last video lectures, we have already derived for series RLC circuit Q is given by 1 upon R under root of L by C. Am I right? Right now the Q factor is 100, so I'll say 100 equal to 1 upon R under root of L by C. I'll say this as equation number 1. Moving ahead, they say the values of R, L and C are doubled now. It means R becomes 2R, L becomes twice of L and C will become twice of C. In effect, what is the new Q factor? So I'll say Q new is equal to 1 upon R has become doubled, so the new value is 2R under root of new value of inductor is twice of L, new value of the capacitor is twice of C. Here 2 gets cancelled. What is remaining is 1 by 2 times 1 upon R under root of L by C. I'll say Q new is equal to 1 by 2 times 1 upon R under root of L by C. From equation number 1, we can figure it out. It is nothing but the older value of Q, which is 100. So it becomes 50. So new value of the Q factor is 50. You can see option number B is the correct option. Let's move to the next problem now. If you notice, question number 3 and question number 4 similar with a minor change. The same question is now asked for parallel RLC circuit. Let's see. For an parallel RLC circuit with Q factor equal to 100, if the values of R, L and C are doubled, then the Q factor is option A, option B, option C and option D are given. Let's see what is the new value. We have already discussed for parallel RLC circuit, Q is given as R into under root of C by L. If you have noticed, it is exactly reverse that you write in series circuit. In series circuit you write Q equal to 1 upon R under root of L by C. Here you exactly inverse the relation, R into under root of C by L. In this case, the value of Q factor is 100. So I'll say 100 equal to R into under root of C by L. Let me say equation number 1. In the next scenario, what is happening? Every component of the value is doubled. So R becomes 2R, L becomes twice of L and C becomes twice of C. So now the new q factor becomes twice of r under root of twice of c by twice of l. Here 2 gets cancelled. What is remaining? 2 into r under root of c by l. You can see from equation number 1, r times under root of c by l is nothing but 100. So I can say it is 2 times 100. So q new is 200. So the new value of q factor is option C, which is 200. So what is exactly happening is, if RLC values are doubled, then q factor becomes half in case of series RLC circuit, and the same q factor becomes doubled if it is parallel RLC circuit. Let's move to the next problem now. Question number 5 is now appeared on your screen. What it says, what is the value of C that results into unity power factor? Please remember, these are some indications that let you know that it's a series RLC or parallel RLC resonance circuit, or the sum is related to parallel resonance or series resonance circuit. Question number 5 is displayed on the screen, which says, what value of C that results into unity power factor? Please remember, these are some indications. When they say unity power factor, it means the problem is related with resonance circuit. Because under resonance only, we know the fact that voltage and current comes in the same phase, or phase angle between voltage and current is equal to 0 degree, or we say power factor equal to what? Unity. Because if phi is equal to 0 degree, that is nothing but phase angle between voltage and current, it means cos 0 becomes 1. So power factor is unity. It means it is actually related with resonance condition. So we need to assume that at frequency equal to 50 Hz, resonance must have occurred. Exactly what happens when resonance occur? At resonance, imaginary part of the impedance or admittance becomes equal to 0. And the same strategy we are going to apply in order to get the value of C, which results into unity power factor. Imaginary part of impedance Z or admittance Y is always equal to 0. The same strategy now we are going to use here. As you can see, this is a parallel circuit. It is always advisable in parallel circuit you should go for admittance calculation rather than impedance calculation. So let's see what we can do here. I can write Y equivalent as 1 upon ZC plus 1 upon ZL. Am I right? So now Y equivalent becomes 1 upon ZC, that is 1 upon minus J times XC, plus 1 upon ZL, and ZL was given as 30 at an angle of 40 degree ohms. So I can write 1 upon 30 at an angle of 40 degree. I can rewrite this as Y equivalent equal to 1 upon minus J. XC is nothing but 1 upon omega C, or omega can be written as 2 pi F times C, plus 1 upon 30 at an angle of 40 degree. Further, I can simplify Y equivalent as minus J can be taken as plus J in the numerator. So it becomes plus J, as well as 1 upon 2 pi FC will become 2 pi FC simply. So it is 2 pi, F is given as 50 times C, plus the second term can be written as 1 upon 30 as magnitude. At an angle, it is minus 40 degree. These are simple polar rules. If no angle is there, I can take this angle as 0 degree. When polar values are divided, their angles get subtracted. So it is 0 minus 40, effective angle is minus 40 degree. Y equivalent I can write J times 2 pi into 50 into C, plus. Now, we know the reality that we have to equate imaginary part equal to 0. To have imaginary part, the whole term should be converted into rectangular format. As you can see, the second part is in polar form. We can convert it into rectangular form like this. It is 1 by 30 cos of minus 40 minus J 1 upon 30 sine of 30. What I can do is, I can take first part and second part together. And we can say imaginary part of Y equivalent is equal to 0. which will result into J 2 pi 50 into C minus J 1 upon 30 sine of 30 equal to 0. Or I can say J 2 pi 50 into C. I can take negative term there becomes positive, which is J times 1 upon 30 sine of 30. Here J and J will get cancelled. What we want is the value of C at resonance, and you know the fact that this equation is valid only when it is under resonance. So C is equal to simply 1 upon 2 pi into 50 multiplied by 30 sine of 30. And finally, if you calculate this, you'll get the value of C as 68.2 microfarad. Finally, we got the value of capacitor assuming resonance condition. That is nothing but a condition where unity power factor is obtained. So this is the final answer, that is C 68.2 microfarad has to be a value of capacitor in order to get unity power factor. So I'm sure you have understood all the 5 problems. Thank you.